Hi guys, so today is going to be a 2-day lesson, so we're just going to be doing part 1 first. And so our essential question is, how can I write functions using function notation? So I'm going to highlight that, and that's what I want you to write down. All right, so Miss Young is going to go.
Okay, so if you look below, you see f of x equals 5x plus 3. We're going to talk about f of x in a minute, but that is called the output value. Another way of thinking of f of x, if Miss Boyd wants to write, is actually equal to y.
Oh yeah, so it's just your answer. if you
Right,
were to
it's your
plug in a
answer.
number.
So
Okay.
x is always your input and y is always your output. So for example, if you wanted to find what's the value of our output if our input is 1.
So it's telling you you want to plug 1 into the equation
Yep.
to get your answer.
For x, and then you get your answer. That's
Okay.
all it's saying. Now I want to float down and show you the caution. When f of x does not mean f times x, I want to
Okay.
make sure, or f multiplied by x. It does
Gotcha.
not mean that. It's actually a value or an answer after plugging in x, a number
Okay.
for x.
Got it.
All right. So if you look, f of x, f is called the name of the function.
Okay.
The output f of x, remember we said that's the same thing as y, is always the dependent variable
Okay.
because it depends on the input.
Okay, so we can't get an answer unless we know what we're plugging in.
Right.
So it's going to depend on what we're plugging in, so it has to be the dependent variable.
Correct.
Okay.
And x is always the independent variable. X
Alright.
doesn't depend on anything. That's what we're plugging in.
Just plug it in.
Yep.
Okay.
Now I want to show you something on the next screen right here. As you can see, the independent variable is always along the horizontal axis on a graph, and the dependent variable, the y, is always on the vertical axis
Okay.
of a graph.
So we said this is like y.
Yep.
And if I were to say plug in any number here, like
Right.
3.
Correct.
Oh boy, that's a big number. I can't do that in my head.
No.
Let me say I plugged in 1.
That's easy.
So if I plugged in 1, that's my independent because that's what I'm plugging in.
Correct.
So if I went over 1,
Right.
then it would depend on what I plugged in to get my answer.
Right.
Plugged in 1, it would be 65.
Correct.
Bam, right there.
So maybe on the
Okay.
graph here, if we want to write, we could write independent, it's like x, or in this case they're using t, but it doesn't matter. Your dependent is y.
Okay.
Okay, let's try an example here. What we're going to ask you to do here is we're going to give you a function, and we're going to evaluate that function when x is equal to 0, 1/2, and -2.
Okay, so we're going to have 3 different equations.
3 different.
Okay, so like you were saying before, this is our number that we care about, that
Right.
we're plugging in.
Right.
And so it's saying f of 0, so we're going
Right.
to write that. F of 0 equals 8 plus 4, and instead of x now, we're actually going to plug in our number.
Right.
So I'll plug in 0.
Correct.
Okay, so we solve that. We get f of 0 equals, well, this just is 0.
Yep.
So 0 plus, or 8 plus 0. And then, Miss Young, do we write f of x here, or do we keep going f of 0?
In this case, we should do f of 0.
Okay. Since they told us what it is,
Right.
f of 0 then
Is equal to
8.
8. And actually, Miss Boyd just asked a really good question, because the only time you leave it as f of x is when you have x in your equation, like 8
Okay.
plus 4x.
Okay.
But if you plug a number in, it's no longer f of x. It's
Okay.
f of whatever the input is.
Got it.
So let's try 1/2.
All right, f of 1/2 equals, and we just write the same equation,
Yep.
8 plus 4, and now this time I'm plugging in the 1/2.
Correct.
All right, so we'll keep solving. Well,
Mhm.
4 times 1/2, half of 4 is 2.
Correct.
We got to add the 8 and bring down our f of 1/2.
Mm-hmm.
All right, and then we just get it equals 10.
Right. And that's our answer. Notice she left it as f of 1/2 equals 10. There's our second answer.
Okay.
We have one more. F of -2.
F of -2 equals 8 plus 4. I'm going to plug in that -2 because that's the number it tells us to plug
Correct.
in.
Yep.
All right, so f of -2 equals 8. And now this time, 4 times a -2 is a
-8.
Okay, so f of -2 equals, well, they just make
Cancel. 0. And there we go.
All right.
All right, let's move on. I think if I recall, example 2 we're going to do in class. But now let's go down to example 3. It's a little bit different. You're not given a function this time.
Oh,
See, there's no function. You're
Okay.
given a graph, and we have to evaluate using the graph. We have to find f of 0, f of 1/2, and f of -2.
okay.
Well, we can do that because what does 0, 1/2, and -2 represent? Is
Those
that
are
our
x's.
input? That's our
Yeah.
x's, right.
So that's an X, that's an X. Oh boy. And that's an X.
Correct.
Oh, and here's our X-axis.
Right. And so basically, we're trying to find the output. So f of 0,
So
we're going to do the point.
Sure.
Sure. So when x is equal to 0, what is y equal
We
to?
gotta find where it crosses
So-
our graph.
Right, and that would
It's right
be
here.
3. So there's 1 point. We might as well go and figure out all the points, and then we can write
Sure.
our equations. 1/2,
So if I go over a half, oh,
that's
it's on
it.
there.
So that's 0. And
And then
-2.
So if I go a -2, I have to go up 1, 2, 3,
4.
4 to touch my graph.
So that would be -2, 4. So when you
Okay.
write your final answer, we're going to write it like we did the last time. We'll write f of 0.
F of 0.
So that is going to equal what? That's going to
3.
equal 3. Correct. F of 1/2 is going to equal 0. And f of -2 is going to equal 4. Perfect.
Nice.
That's it.
That's easy enough.
All right, next page. Oh,
There's
that's
the
it.
questions.
So work on those, and we will see you tomorrow.
Bye.